Guys, get up. Get up, get up, get up. Come. इनको बैठने को बोलो सर. जाओ. Request करो, please बैठ जाइए. Sir, gentlemen, can we please take up the seats, please? Sorry to be a little harsh, but have to be strict because we have a lot to cover in a day. With your due permission, we would like to start this session. So, ladies and gentlemen, take up your seats, please. Refrain from standing near the stage. Request everyone to kindly settle down fast. Put your mobile phones on silent mode or vibrating mode if you've not done. Thank you. Ladies and gentlemen, to begin, we have Colonel Anurag Awasthi, Vice President of IESA. Colonel Awasthi will present the Semiconductor Supply Chain Report, mapping out the inputs, chemicals and gases required for the semiconductor industry. Humbly request to those who are standing to take up your seats, please, before we invite the first speaker on the stage. Ladies and gentlemen, please help me welcome Colonel Anurag Awasthi on the stage for his presentation. Welcome, sir. It is indeed our pleasure to have you with us. Yes, please. Yes, warm up, guys. Thank you.
Can I have the slide sorter, please? Yeah. All right. Can you hear me at the back? Can you hear me at the back? All right. I have 10 to 12 minutes and I will stick to the designated time given to me, and I will not stand between you and your lunch, and make sure the other people also don't do the same. Having said that, this session is a very, very important session in which the basic metrics of this session is that I will give you the latest version of the supply chain report and the semiconductor manufacturing, which is being hedged by us from the very top and is going to be released very soon. So I'll give you a small little expose on that. This will be followed up by the DG of Indian Chemical Council, who will give you the Indian perspective, followed up by the Gujarat Chemical Council, which will give you the Gujarat perspective, and then it will be a panel discussion. So it's a funnel flow. I'll give you the bigger picture. It comes to India, then it comes to Gujarat, and then we go in for a panel discussion. It's more of a knowledge session, but I will make it very clear as to what the report basically hedges to and what it needs to do. Now, Indian Electronics and Semiconductor Association made this report earlier in 2022. If you see most of the, things and the conferences which are being held abroad, a lot of these reports go there because it's a very well-made report. Our partner in this report is one of the best consulting firms in India called Feedback Advisory. The CEO is here. Can you please stand up, Dave? So you can meet with him at some stage in time and ask him as to how this report is being made. Now, this report is going to be released very soon and will give you all the metrics insofar as the chemical industry in this country is concerned and how it dovetails with the semiconductor industry in times to come. Having said that, let me give you a semicon snapshot first. You can take this presentation for me. There's no point clicking it. You can just take it. I mean, you can ask them and take it. Right, when you're looking at the numbers, sheer numbers, you're looking at design and software patents, $21 billion. Industrial and machine automation, 107. Silicon wafers and specialty chemicals, $75 billion. This is the global outlook. These numbers are staggering. Thereafter, you go on to the semiconductor device industry, in which you're looking at 130 billion for the external integrated circuit wafer factories, and nearly 49 billion for the OSATs or the ATMPs. Coming to the end-use application of $573 billion, you can see the pie chart. This is exactly how the semiconductor industry is panned out as of December of 2023 last year. So in this, you can imagine the kind of work and the interplay the chemical industry has to make this system move forward. By the way, the Indian chemical industry is the 6th largest in the world and contributes to 8% of Indian GDP, for all people who don't know. So the amount of interest which is going to be generated in this segment is going to be very, very huge. Right. So the first edition of the report, these were the recommendations that we had given. And the current metrics are, you've just seen Sagar was here, the Indian Semiconductor Mission has been established as a specialized and independent business division. The ISM has been established at an overall level as a task force. The Semicon India program has come. You've all seen, I will not repeat what has been said as to who's coming and who's going to be coming in the future. And qualification labs in semiconductor manufacturing supply chain SIL Council is yet to be established. But the Indian workforce now is currently focusing only on VLSI, which needs a little tweak. Having said that, the second edition of this report gives you the edition only focuses on a deep dive into the Indian readiness of the global semiconductor manufacturing supply chain ecosystem fully, completely, including the rare earths, including the chemicals, including the gases, including materials, and how they are going to be moving out in times to come. Thereafter, key focus also includes equipment ecosystem, requirement of material, services, and skills, also provides a view on the expected potential which is available to be serviced from India by 2030, that we are looking at by 2030, we are looking at the semiconductor market in India to touch somewhere close to 100 billion USD. That's the metrics which has come out in our market report. And then, of course, the key action points to speed up supplies and all of that, which forms a part of the recommendations of the entire report. Now, having said that, this is the current scenario. This is how it looks like. Large OEMs maintain presence in India, but no large-scale equipment manufacturing is taking place. Most of the equipment used in semiconductor production are customized, built to print, and specific to requirement of the end customer, whichever fab it is. And component or equipment supplier lacks education of the manufacturing process as well as storage methods. And parts and component suppliers are expected to maintain certifications. There are various certifications, too many of them actually, which need to be looked into. The opportunities are many, which is there on the slide. I will not repeat them, but having all this on the slide, the most important part is that both critical and non-critical components require to undergo a very stringent qualification process. That is the bottleneck of the whole system, the qualification process. Having said that, the report takes a deep dive into the ultra high purity delivery system, the wet chemistry, wafer processing, and of course the sustainability and the environmental issues, especially with keeping the sustainable development goals, the 17 SDGs of the United Nations in mind, which obviously India is going to be a very, very big player because you're starting from bottoms up. So you will incorporate the best practices because most of the fabs were built in end 90s, early 2000s, which is a fact. So you're going to be incorporating a lot of green processes into the Indian policy and the systems. A lot of people don't understand that, but be that as it may, we are going to be incorporating all of this, and it's going to be the world-class segment as I look at it today. Right. So I will not go into this major chart since I am a little on a lack of time. I will only give you a small approach to qualification of materials. These famous 8 steps, kindly have a look at it. First you define, then you certify, then an existing use case analysis, then samples, testing of samples to see stability, performance, and results in the desired process application. Then, of course, their performance in the end-use market, and then the product is qualified or rejected. So look at this process. This process needs to be understood, and this is a part of one of the recommendations that this report now spins out, that at the end of the day, you may have a huge amount of infrastructure, you may put in a lot of money insofar as the chemical domain is concerned. You may move in from parts per million to parts per billion, whatever have you, but what about the qualification criteria? That has to come in. So this report takes a deep dive into it. Gases. A lot of people have to understand gases. There are issues of cartage, there are issues of storage, there are issues of purity, there are issues of shelf life, there are issues of disposal, there are issues of pyrotoxicity. I mean, the list is endless. And most of the times, gases cannot be transported by air. They have to take the sea route. That also has to be very clearly understood by a lot of policymakers, a lot of thinkers, a lot of industry leaders like you who are sitting here. Having said that, there are challenges. Handling and logistics is a challenge. Storage and shelf life is a challenge. Surinder sir is here. He's headed the Semiconductor Laboratory in Mohali. In your spare time, kindly meet him. Ask him the kind of challenges SCL Mohali has had in terms of gases and chemicals. It's staggering. I mean, it may look very simple to you, but the way is very, very complex. It also entails even movement, the storage. How do you have the containers? What is their shelf life? Do you have cryogenic containers to move it from place A to place B without altering the basic, structure of the gases, which is very, very important because these processes are complex, as the previous panel brought out. I think it's one of the most complex endeavor known to man to make a semiconductor chip. So this also has to be factored. This report brings out a lot of things insofar as this is concerned. Then, of course, since we've just seen the earthquake in Taiwan and a lot of other things which are, actually force majeure, as they call it in legal terms, the world also requires some de-risking in some place or the other. India is a destination. So you look at this overall global market potential today, as we speak, is $420 billion. The potential for India today in terms of equipments, materials, and end-to-end services comes to somewhere around USD 40 billion. And in the potential current state of play, we are looking at USD 10 billion, which can increase. But see how it's happening. There are massive G2G initiatives. Quad is one of them. IMEC is one of them. The initiative on critical and emerging technologies with the United States is one of them, in spite of the CHIPS Act, which has come into place, and the European CHIPS Act coming into being. And of course, the India-Japan chip supply chain partnership also is going to be taking place post the MOU has been signed. So a lot of incidents are happening insofar as the G2G space is concerned, the association to association space is concerned, and B2B businesses are concerned. How we leverage them, get it to a particular level, and take it to its logical conclusion is all amongst all of us, how we do it. So no man is an island, or no man or woman is an island. We need to do this together. So this is what it looks like from the broader view. So there is a massive scope to supply products. There are nearly 150 chemicals and gases which are used for the semiconductor supply chain and for manufacturing the same, including the packaging domain. Having said that, equipment is built to print parts, gas purification systems and chemical delivery systems, plastic molds, very important, sheet metal fabrication, investment, castings, metal machining, scope for ER&D services. So the opportunities are limitless. Chemicals is just the important ones listed out. There are nearly 150, sir, Surinder sir, 150 odd. 150 odd chemicals and gases, including bulk and specialty, including photoresists, so many of them. The genres are many. Gases, so many of them, and services. Now in equipment to accelerate the growth and potential sourcing capability, it will be important to include equipment in the Indian semiconductor mission. Leverage local talent. Large specialty chemical companies currently offer products with high level of purity. However, to match semiconductor grade is a challenge. Why is it a challenge? Because from moving from 99 to 99.99% semiconductor purity requires money, investment, and nobody would put that money because there was no market. The market exists now. It's increasing. So you need to look at it the same way. There's a need for an independent high-quality lab which will assist the firms achieve these desired purity levels. Now, this is an important part. Although the Honorable Minister of State last time around in the government also indicated that the Semiconductor Laboratory will become the Bharat Research facility, but at the end of the day, you require more labs. And of course, most important, skilling. Skilling of workforce is not only for fabs, it is not for designs, it is for handlings of chemicals, handling of gases, running that entire supply chain metrics inside a fabrication facility. So that training also is very, very important. Now, how do we do it? Whether we skill them here, we send them out, we get somebody here. I mean, this is all left to the imagination of all of you. So needless to say, it is a skilling and a very complex matter. Market landscape, I will not go into it. The prospective roadmap and opportunity is very, very high. There's a scope to target around 8 to 10% of the global demand by 2030 by India. Potential identified in 7 areas, in equipment, 15 odd chemicals. We have a joint task force with the Indian Chemical Council. We've already had the first sitting in which we've already mapped who is making what and where. That's the first step. There are some people who are making these things, but who and where, and in what grade, and in what capacities. That has already been mapped. We are going ahead more on that. 10 gases, 8 service categories to be a part of this opportunity. Indian MSMEs and large companies targeting specialized industries as all these mentioned. Specialty chemicals have a proven success record in the export market. Everybody wants them. So all you people sitting from the chemical industry, please look at them. The report will come out, please see, it brings out very clearly which are the specialty chemicals which are required for the semicon industry. Look at it. Maybe work in the same manner and the same trajectory, so to say. And huge potential to address the global services. We are giving some prospective roadmap. There's those 7 points. You can have a look at it. It's just a small little teaser because the report is very big. It's around 100 or maybe more than 100 pages. So it will give you a major look as to how the system is going to be panning out globally and how it comes down insofar as the Indian context is concerned with the present metrics and the futuristic metrics. And with that, I rest my case. I am dot on target. Thank you very much. I will not stand between you and your lunch. Thank you.
Thank you very much, sir, for that crisp but very knowledgeable and important presentation of yours. And I would request Dr. Narottam Sahu, Advisor and Member Secretary, to kindly felicitate sir. Sir, can you step on the dais, please? Thank you very much. Next, we are pleased to have Mr. D. Soti Selvam, Director General of ICC, who will discuss supply chain management for chemicals and gases in the semiconductor industry. His insights will be invaluable for understanding the logistical challenges and solutions in this sector. We welcome you, sir. Can we extend a warm welcome, ladies and gentlemen? Thank you.
Good afternoon. At the outset, let me thank the organizers for having given this excellent opportunity for Indian Chemical Council to say a few words about the chemical industry's role in the semiconductor manufacture. Let's go to the first slide. Yeah, give me that. Well, the purpose of my presentation was actually to present the opportunities, the challenges associated with that, and the support required from the government. But I'll also take this opportunity to give a few insights about the industry and about ICC as well. Indian Chemical Council represents the $220 billion chemical and petrochemical industry in India. We are a member of the International Council of Chemical Associations, which represents 90% of the global chemical industry. ICC represents about 80% of the chemical industry. We have an MOU, as Colonel Avasthi said, with IESA, and we're working very closely towards mapping the chemicals against the manufacturers. At this point of a time, the semiconductor grade chemicals are not manufactured in India. So there's a huge opportunity, but along with the opportunity comes the challenges as well. And Mr. Ashwin Shroff, who is here, chairman of the Excel Group, is the task force chairman. We are actively working on what is required for the semiconductor grade chemicals. Now, this semiconductor grade chemicals can be looked at in different ways. It can be looked at based on the type, based on the end use, and based on the application. Now, if you look at it from the way the chemicals are applied, it can be grouped under etching chemicals, deposition chemicals, cleaning solutions, dopants, lithography chemicals, and finally inert and reactive gases. You see the chemicals, some examples I've shown there, but it may look very simple. But these are not simple industrial grades which are being used in the semiconductor industry. There, the purity levels are at the ppb, ppt levels, parts per billion, parts per trillion levels. It's just not the purity alone. They come in as formulations, and the recipes are generally very secret, at least in most of the cases. So that's the point. There's a big list of more than around 250 chemicals, and the numbers are only increasing as we see more and more in reports. But the major ones are listed here. Now, the important chemicals and gases and the minerals are shown here. Now, sulfuric acid, hydrochloric acid, ammonia, they all look very simple. They are normal chemicals which are industrial chemicals which are in use. I repeat, they are different. That's why they get classified under specialty chemicals. Otherwise they are commodity chemicals, but because they have to achieve that very high level of purity, and also when it comes to application, they come in as recipe in formulations, and along with that, a few other ingredients are also added. So that's how things are. So that makes it more complicated. Now, this talks about the semiconductor market. Based on the semiconductor usage in the country, the projected market for chemicals, assuming that whatever semiconductors are going to be, what the Indian consumption is going to be made in the country, the projected market size for chemicals is about 22,500 crores, which is likely to go to 67,000 crores. It's a huge number. But right now, again, I'm repeating, nothing is being manufactured. Only industrial chemicals are being manufactured. More than 250 chemicals of different types are being used. Now, this just to give you an idea about the chemical and petrochemical industry in India. This is based on a report ICC made along with McKinsey. The chemical industry is growing at a very fast pace. Now, it is expected to touch a $1 trillion mark by 2040. Now, within the chemical and petrochemical business, the specialty sector is growing in a much, much bigger pace. Now, if you add the semiconductor chemicals to it, this pace is going to only go up. You can see the specialty chemical market is expected to grow at 11 to 12% and is expected to reach a figure of about 140 to 190 million. And as Colonel Awasthi said, we are already doing very well in the specialty chemical sector, and we are exporting a lot of product. This is one segment where we are trade surplus. So there's a lot of potential for the chemical industry to get into this area. And where are these specialty chemicals made? Of course, Gujarat stands number 1, followed by Maharashtra, third is Tamil Nadu, and there are a couple of other states. But these 3 states alone contribute a sizable chunk of the specialty chemicals being made. Now comes the issues. Now, how do I make this? Is it so easy to make? Definitely no. First thing is technology. It is just not the purity levels. As I say, these chemicals are given as formulations, typical of something like the latest engine oils. Because I worked in the lubricant industry before. These engine oils, the formulations are supplied, the additives are supplied by companies like Lubrizol, Chevron, etc. And especially for the modern engines, they are very complex. Not that everybody can make it. So the purity levels and the recipes is a challenge. The next is the investments. You see, upgrading a chemical plant to produce high purities electronic grade chemicals requires huge investment. It can range from 5 million to 20 million investment. Now what do we do? Are we going to, if this Indian semiconductor industry has to be competitive, okay, we have set up shop in India. That doesn't mean that they are going to be competitive. So you need to have the materials in place around. In fact, everybody in the morning session, they pointed about creating an ecosystem, having, the ancillary systems around. So that is what is required for the semiconductor industry also. So therefore, these chemicals need to be manufactured in India sooner or later. Maybe initially it may have to be imported, but if you have to be competitive, definitely these products have to be made in India. So apart from that, the challenges are stringent environment norms, then high risk management measures, because it is much more than the normal risk management measures. Longer periods for vendor qualification. Approvals don't come so easily from the qualification labs as well as from the semiconductor manufacturers. Regulatory compliance and approvals, the need for qualification labs now. You can't send every sample outside the country to get it verified and certified. So you need qualification labs. These are some of the important challenges being faced for the chemical industry if it has to be really ready for the semiconductor industry. Now, opportunities, as I said, it's a fantastic opportunity awaits us. As I said, we're growing very rapidly in specialty chemicals, and the potential for semiconductor chemicals is quite high. And once you qualify your products also, you get an opportunity to cater to the global semiconductor market. Now comes the opportunity. How do we do it? Now, immediately, one cannot pump in billions of dollars into R&D and then get these chemicals out, semiconductor ready. So obviously there are players. I've only shown a couple of them. Many of them are ICC members, and a few of them I would not have mentioned here. But these are people who are already in this business. I've spoken to a couple of them like Dow, BASF, etc. They are interested in setting up a joint venture in India. So people, I think previous session, a gentleman asked me how to do it. Now, right now the way is to set up joint ventures. We need to, get in touch with these companies and then create the joint ventures in India. That's the way to move. Now, semiconductor industry has got a lot of incentives. Now, naturally, the semiconductor chemicals and gases industry also require incentives so that they become competitive, so that the semiconductor industry also becomes very competitive globally. So these are some of the suggestions. One central agency, because today, for example, few days back, there was an interaction with the Department of Chemicals and Petrochemicals. To be very frank with you, they were not fully aware of what's happening in Gujarat, actually. So my point is, okay, I'll hurry up. So one central agency to coordinate with various ministries, invitation to global players to invest in India, CapEx incentives are required, and we need to aid companies with a special PLI scheme. Of course, PLI scheme for chemicals itself has not been announced so far. We need a special PLI scheme, special R&D scheme, facilitating setting up of qualification labs, which is absolutely required, and finally, of course, skill upgradation. So these are some of the important supports, things which are required from the government if this chemicals and gases for the semiconductor industry has to be perfected in India. With these few words, let me thank once again the organizers for giving this opportunity. Thank you so much.
Thank you very much, sir, for that enlightening presentation. And I would now request Dr. Narottam Sahu to kindly do the gesture of presenting the memento. Thank you. Now we have Dr. Jaimin Vasa, President of the Gujarat Chemical Association, and he'll share insights on opportunities for the chemical industry in Gujarat to cater to the evolving semiconductor industry. His talk will highlight how Gujarat can play a significant role in this sector. Can we welcome him with a warm applause? Thank you.
Very good afternoon, friends. Our moderator, Mr. Surinder Singh, Mr. Avasthi, my friend, my fellow speaker, Mr. Dr. Selvam, other panelists, Mr. Narottam, and respected delegates. I'm honored to stand here before you today to discuss a topic of immense significance. The opportunities what Gujarat chemical industry has in serving the evolving semiconductor industry. As recently shown by Dr. Selvan, that market size of chemicals and petrochemical sector in India is around $250 billion, and which is expected to grow to $300 billion by 2025. Today, India ranks 6th in the world and 3rd in Asia as a chemical producer, out of which Gujarat contributes more than 30% of chemicals production and exports. Friends, as we have been given a lot of figures and lot of apprehension about how Gujarat or Indian chemical manufacturers can match the specification, that's what semiconductor industry requires. I'll just tell that necessity is the mother of invention. Gujarat is an entrepreneurial state. India is also an entrepreneurial country. And I personally say that whatever kind of quality is required, Gujarat chemical manufacturers and Indian chemical manufacturers are well equipped with. And we have in Gujarat and Ahmedabad very good laboratories. Of course, it is not made for looking to the semiconductor industry, but once it is required to be done, I think none of the Gujarat entrepreneur or Indian entrepreneur is not capable of doing it. Say, friends, this, as we all know, the use in various everyday devices like computers, smartphones, TVs, is also used for advanced technology like medical equipment, military systems, and many other applications. And they are a part of our daily lives. The global semiconductor chemicals market, as shown by us, was valued $12.2 billion in 2023 and is projected to reach $21.9 billion by 2028, growing at the rate of 12.3% CAGR from 2023 to 28. See, we have successfully created Gujarat as an ecosystem in Gujarat. Secondly, a big chemical industries, PS and the PSU are there in Gujarat. They are capable of manufacturing the chemicals and other products in bulk and as per the specification required by the semiconductor industry. This time I would be very happy to mention an example. Earlier pharmaceutical industry wanted to start, and that was same was told that can Gujarat is able to manufacture the quality as for the pharmaceutical industry? Yes, we did it. Same in the case of defense. Can Gujarat is capable of manufacturing the defense equipments? Yes, we made it. Today, as recently shown by Dr. Selvam, Gujarat contributes 40% of specialty chemical market of India. So I think the best thing is compared to the competitive advantage of specialty chemicals in Gujarat is there are many competitive advantages for specialty chemical in Gujarat. 40% cargo of the entire country is handled by Gujarat ports. Gujarat enjoys the status of industrially developed state of India, and Gujarat has emerged as one of the top states in India with excellent infrastructure for technical education, longest coastline, say about 1,600 kilometers, with 48 seaports and 5,300 kilometer long railway network, 19 airports including 2 international airports, and 75,000 plus kilometer of road network, and 7,873 kilometer national highways, which is, and also we all know that Gujarat is a power supply state, surplus state. Dear friends, Gujarat is one among the few states within India which can offer a complete ecosystem offering that will ensure a success of a prominent high-tech chemical companies. Gujarat is the chemical hub of India and producing nearly 50% of the chemicals within India. Gujarat is a home to a thriving chemical sector and playing significant role in supplying the same to various industries across the state and the world. Being a 6% of India's geographical area and 5% of India's population, Gujarat's chemical industry contribute 62% of the petrochemical industry. As we all know that Gujarat has the largest two refineries in India's two largest refineries in Gujarat, and also Gujarat production, the chemical production 30% share. India total export is 9% of India is from Gujarat. 9% GDP contribution. It is also positioned as the petrochemical and chemical capital of India and has a marginal role in the growing economy of India. Gujarat PCPIR Petroleum Chemicals and Petrochemicals Investment Region at Dahej, which is spread over 453 square kilometers of area, is only working PCPIR in India and have worked the class infrastructure with competitive environment and conducive for setting up the chemical business in India, which is required for the semiconductor industry. Gujarat has the availability of chemicals like recently said by Dr. Sulfuric acid, SCL, nitric acid, hydrogen peroxide, ethanol, carbon, etc., and gases like oxygen, nitrogen, argon, carbon dioxide, which can be supplied to chemical industry manufacture across the globe as per the specification required. Gujarat has a well-established supply chain of the several key chemicals consumed by the semiconductor industry. Many domestic companies have expressed interest to augment their facilities to meet the demand of the semiconductor sector, and the top three chemical suppliers in Gujarat are Linde India, BSF India, and Solvay India. Still, there is a wide gap for the supply side of the semiconductor sectors. Nearly 250 specialty gases and chemicals are required for semiconductor industry, and some of the chemicals commonly used, which has been shown by my experts, chemicals are the photoresistance, which is used in the philography to transfer circuit patterns into the silicon wafers. Etchants, this is chemicals used for the selectively remove material layers during the etching process. Solvent for the cleaning purposes. DuPont's, this chemical used to introduce impurities into silicon to alter its electronic properties, and acids and bases are used in the cleaning, etching, and pH adjustment processes. Then developers, chemical mechanism, planism, and slurries used for polishing surfaces to achieve flatness. Oxidizers also used in create oxide layers, and last but not the least, lubricant and surfactants used in various stages, and hydrogen peroxide is also used as a cleaning and etching chemicals, which is very rich. In Gujarat is rich in all these chemicals. And all these chemicals are critical for different stages of semiconductor fabrication, from vapor preparation to doping, patterning, and packing, and the demand of these chemicals are increasingly consistently owing to the enormous demand from modern technology industries, including modern communications, computers, microcomputers, mechanical intelligence system, and industrial automation and home appliances. Now, we all know that semiconductor specialty chemical manufacturing process, including the raw material processing, may involve purification, filtration, distillation, or other steps to ensure the desired purity and quality of the raw materials. And after synthesis, the crude product undergoes rigorous purification and filtration steps to remove impurities and ensure the highest purity levels required by the semiconductor industries. So, friend, also, I would like to highlight commonly used gases has been shown: nitrogen, oxygen, argon gas, hydrogens, and also the hydrogen. These use of hydrogen in semiconductor manufacturing may increase due to higher demand. Specifically in the photolithography stage, hydrogen is used to react with the chemical tin. Now this importance, as recently said by this, seamless supply chains are crucial for the semiconductor industry, but Gujarat can strengthen its logistic and supply chain infrastructure to ensure timely delivery of a critical chemical and materials to semiconductor manufacture worldwide. We know that three big companies, 80% investment which has come in semiconductor industry in Gujarat. So naturally, we don't have to prove that Gujarat is the right state for the ecosystem, and it will make sure that all semiconductor industry will have the same quality of material required, same kind of logistics, same kind of supply chain. Also, collaboration, recently shown that between Gujarat-based chemical companies and global semiconductor giants can foster innovation and knowledge exchange. Joint ventures and strategic partnership can accelerate technological advancements and market penetration. So, for utilizing this opportunity favorably by the chemical industry, Gujarat government should provide support through incentives, subsidies, and infrastructure development to attract the investment in chemical manufacturing for semiconductors. Friends, opportunities are immense for Gujarat chemical industry to cater to the evolving semiconductor industry are vast and promising. By capitalizing on its strength in manufacturing, innovation, and infrastructure, Gujarat can emerge a very big key player in the global semiconductor supply chain. Together, we can pave the way for a future where technological advancements are not just a possibility, but are really driven, and it's a reality driven by Gujarat's ingenuity and vision. And I'm sure Gujarat can match any kind of challenges and can take any kind of challenges to make sure that more and more semiconductor industry start investing in Gujarat. Thank you so much.
Thank you very much, Dr. Jaimin Vasa, and request Dr. Narottam Sahu to do the honors of presenting the token of gesture, the memento. Ladies and gentlemen, now we move to our panel discussion on setting up ecosystem. Thank you. Thank you, sir. Now we move to our panel discussion on setting up ecosystem for semiconductor chemicals industry. Our discussion will be moderated by Mr. Surinder Singh, advisor, technical at ISM. Welcome, sir. Just give us a moment to set the stage. Thank you. Okay, ladies and gentlemen, it's our pleasure to invite the moderator of this session, Mr. Surinder Singh, advisor technical at ISM. Welcome, sir. And we take a pleasure to introduce our esteemed panelists, Mr. Subir Ganguly, Head On-Site Business Development at Inox, Mr. Ashwin Shroff, Chairman and MD at Excel Industries, Mr. Pankaj Mehta, President Strategy at Aarti Industries Limited, Mr. Ashutosh Bhabhe, Co-Founder and CEO at 14 SI Solutions, Mr. Renard Benoit, MD at Air Liquid, Mr. Gary Chuang, Senior Department Manager, Procurement Department at PSMC. We request the moderator and the panelists to kindly step on the stage, please. Mr. Singh will guide this engaging discussion exploring the various aspects of setting up a robust ecosystem for the semiconductor chemicals industry. Ladies and gentlemen, a small announcement to be made. A lady has lost her bag. They are similar to what you have received, but her visiting cards are there inside the bag and a charger, which is very important to charge her mobile and her life. So if you find it, her name is Gurpreet, the visiting card has that. So if you find the bag, you can deposit over here. Thank you. Yes, Surinder sir, you can take over. Thank you.
Yes, good afternoon to everyone. We are already late by 20 minutes or so. And I think right from the last row, people will start moving very quickly for lunch. So my first request to panelists is, so restrict as much as possible so that they hear your view before leaving. Okay. So as has been now highlighted by the previous session people also, and the keynote speakers here in this session also. So as you have seen the importance of chemical industry, it really plays a very crucial role in almost all aspects of life you have seen. Of course, there are numerous challenges in meeting demands, like now demand has come for semiconductor sector. So there are many challenges, and at the same time, they have responsibility of keeping the safety of environment as well as the well-being of their personal and community in general. As Anurag has brought up in the morning, that this industry in India, that contributes a lot to GDP, almost 8 to 9%. We are the 6th largest in world, 3rd largest in Asia, and of course, there is a healthy contribution to export, or 2 digits, I'll say, in almost last so many years, I'm saying, varying from 10 to 13%. So there is now, I think, time. I say the time has come for this industry in India to explore diversification to cater to the semiconductor, chemical and gases sector. By what is needed is also now has been pointed out by many speakers, so I'll not dwell too much on that, that there are very little efforts which are needed to bring them to the semiconductor grade. And I think opportunities and challenges also has been very well brought out by Anurag and Dr. Selvam. So probably will not take too much time, seeing the time restriction. So we will try to dwell on the experts. Luckily, on the panel, I must compliment the organizers. We have global players on this panel, as well as we have people from the local, the Indian chemical industry present here on the dais. The second is, you have now, by this time from the morning, you know that it is not only the production of chemical and gases, it is the purity of these ingredients which is to be maintained, as well as the other aspects like transportation is equally critical. Okay, so almost all experts are there in this panel, so I'll not take much time. seeing the time paucity, I'll first request all the panelists to introduce themselves, and then probably we'll start with the question.
My name is Ashwin Shroff. I am chairman of Excel Industries. We are one of the oldest chemical companies of India. I have been the past president of the Indian Chemical Council, and we always like to pioneer things, take up things for the first time in the country, and there are many credits to our group. We are a group of 5 companies in chemicals: Excel, Transpec, Agrocell, and there are a few others. And we equally have a number of NGOs who are quite active with the communities, including skill building and affluent management, etc. Thank you.
Good afternoon. My name is Pankaj Mehta. I'm the resident for strategy at Aarti Industries Limited. Aarti is actually a very pretty large-sized specialty chemical company, nearly $1 billion of sales. And we cater to a whole host of industries, and would, of course, looking forward to working with the semiconductor industry also. Personally, I have more than 40 years in the chemical industry, of which 15 years were at DuPont in the US, supporting the semiconductor industry for the handling of chemicals and the handling of wafers. So this actually, I had been hoping for the semiconductor industry to come to India for a long time. Now it is.
Good day, everyone. I'm Gary from Taiwan, PSMC, Power Chip Semiconductor Manufacturing Corporation. And today I am very delighted to be on the behalf of my company to cooperate with Tata Group to make the chip made in India come true. So later we can discuss this issue for supply chain management for a while. Thank you.
Good afternoon, everyone. I'm Ashutosh. First, I'd like to thank the organizers for giving us a small startup like ours, but with big vision, the opportunity to be here. We specialize in the field of contamination control, which is a critical aspect of semiconductor manufacturing. I have personally been in this industry for about 12 years. I've worked at leading edge fabs like Intel for about 4 years in the field of lithography, and then I was a global applications manager for a large supplier, Integris. So there my focus was on filtration and purification of chemistries. And we are now a startup based out of the Indian Institute of Science, Bangalore. And we actually work with customers to help sort of navigate the path to prevent contamination or to minimize contamination and also improve purity of chemicals. So looking forward to the discussion. Thank you.
Hello, everyone. I'm Subir Ganguly, and I work for Inox Air Products, which is a 50-50 joint venture between Air Products and Chemicals US and Inox Group. We are the largest gas manufacturer and supplier in the country. And I have worked in this company for the last 10 years, a little bit more, and I have had experience in this field for the last 20-25 years. And I basically spearhead those large capex projects and the long-term supplies and contracting and managing supply chains. I have been exposed to cryogenics and industrial gases for a pretty long period of time. We have recently closed a deal with Micron in India, which is the first semiconductor manufacturer to be coming to India. And we have contracted for both their main production base as well as the testing, the OSAT one, the smaller one. So basically we are at the forefront at this point in time, and there are several issues we have identified which would be necessary to be overcome as we go along, and as we understood from different speakers, that semiconductor industry is going to be in a very, very progressive stage in India, even though it's a nascent stage at this point in time, and therefore going forward, a lot of capabilities and specialities have to be built in. Thank you. I look forward to this discussion.
Thank you. Good afternoon, everyone. I'm Benoît Renard, the Managing Director of Air Liquide, a French company, worldwide leader in gas industry, supplying gas for electronics, focusing on innovation, on technological expertise, especially for ESM on advanced materials. And I will have the chance to develop a little bit later what about the next step in India, developing this kind of gas and material supply. I've been working for Air Liquide for the past 30 years in the gas industry and in India for the past 3 years. I'm glad to be part of this panel.
Thank you, everyone. So I'll start with Gary. Okay, Gary, knowledge of audience. So I'm just asking you, what is the global scenario for semiconductor, chemical, and gas supply chain? And what are your plans for India now? Anyway, you're
in the first beginning, I suggest India should have followed the best life from Taiwan, PSMC, and then try to manufacture your localization, probably gas, chemical, and every material, and then. But first, you have to notice that how to reach a standard for semiconductor. I don't think it's very easy to achieve because no matter Taiwan, Japan, Korea, or China, they spend a lot of time, many years, to build up a nice environment. Not only the basic infrastructure, but also for human resource and education. And then how to keep them to stay in India, that's quite important. Not only first to absorb them to come back to India and help India to manufacture its own chip. Yeah, I think it takes a long time and long way. And how you to shorten the learning curve in the manufacturing, that's quite important. Yeah.
Thank you. My next question is to Mr. Mehta. The strategies you suggest for innovation and diversification for future expansion of Indian chemical industry or semiconductor sector?
Thank you. Actually, I think for diversification, for example, the Indian chemical industry in general supports all manufacturing industries actually. It's like a foundational industry supporting, for example, pharmaceutical, agriculture, polymers, dyes, you name it, and the industry is supporting. So this is a kind of addition to the wide range of industries that the chemical industry supports. In fact, I look at it, while the fab looks like a clean structure from the outside, it is actually a chemical factory where lots of chemical reactions take place. And the reason that it is, Gujarat is the location of choice is because of the existing chemical ecosystem in Gujarat. So while we talk about an ecosystem to be developed for the semiconductor industry, I would say that the existing ecosystem of the chemical industry is expanding to encompass the semiconductor industry as part of the chemical industry. So that is one. The other thing is what innovation is required. I think what was just said is that the innovation in terms of the current chemical industry is able to handle the hazardous character, the safety aspects, lot of such requirements of the chemical industry. We have a lot of depth and breadth with 80,000 chemicals being handled safely day in and day out. What we need is the applications for the semiconductor industry requires very high purity, contamination control, cleaning up, keeping it clean, storing it clean, transporting it to the facilities, all those, and the metrology. In fact, that's a good point was also made earlier because, for example, we had to send a few samples abroad to be tested. And that cost 10 lakh rupees. You know, when I got the bill, I kind of my team gave me, I said, did we know that it was going to cost so much when we sent the samples? So that sort of a thing will make it much more expensive. So that kind of infrastructure is required to drive the innovation. So I think technology transfer for the specific requirements of the semiconductor industry is required, partnering with the global producers to localize the availability, that is going to be a challenge, and work needs to be worked across. I think the previous speakers also, previous panel, they did mention that that was a potential option to consider. And also the other part is that what is in it for the partners to come here and partner with us? I would say that, you know, the frugal innovation that Indians are well known for, that can help them become competitive in the future also. Like the earlier Tata Projects CEO mentioned about the Chandrayaan mission, you know, that was done at a cost lower than a Hollywood movie. So in that sense, the Indians can also contribute to the global ecosystem, and that's an incentive for the foreign companies to come and partner with us. So I think that's really how we will come across. And of course, shortening the learning curve in working with the foreign partners would be useful. Thanks.
Yeah, thank you. You have very rightly said. It is, see, from the morning you must be hearing that a lot of purity is needed. Typically, as you know, for these chemical and gases, typically about 9 to about 7, 9, we say 9N purity like that. So purity, it is not only the purity, 99.999 is 5N purity, but it is not only just that figure. Sometimes the contaminants what are there are not 1 or 2. You are looking for almost 7 to 10 contaminants. So analysis, as is rightly brought out, the analysis and the metrology is very important. So luckily on our panel, Mr. Asutosh is there, who said that it is a startup. He's a startup, but I could see his work from the web. They are doing really fantastic work. So I'd like to ask him that what is the future now you are envisaging, seeing the current scenario in India for analysis and metrology of these chemicals?
Yeah, so I think we'll break this problem statement down a bit more finely. So basically, if you look at contamination, unfortunately, along with anything you manufacture, however cleanly you do it, contaminants are fundamentally ingrained into any material, any gas, any chemical. The problem is multivariate. It comes from, and it's an ever-evolving problem in the sense that contamination looks like something when it's made, it looks like completely different when it moves through the ecosystem. So what presents as a contaminant in the raw material manifests itself very differently on wafer because along the way it's interacted with a number of things, right? So that's one way of thinking about contamination. The other future trends of contamination, and for me it's great to be in this business in that sense because contamination, even in the sense of trends, is an ever-evolving problem statement. What is a problem yesterday continues to remain a problem tomorrow. But what was not a problem yesterday suddenly becomes a problem today and becomes an even bigger problem tomorrow. And as you move to newer transistor designs like gate-all-around, you move to newer power delivery systems, you move to newer packaging development, all of these fundamentally change the integration scheme of how a transistor or how a semiconductor device is built. And what that means is that there is a direct effect on what suddenly becomes a contaminant. For the longest times, organic contamination was sort of the neglected part. Not many people looked at it. People are focused on particulates, people are focused on metallics, but now the industry trend is heavily involved in understanding what organic contaminants are. Just giving you a simple example of how the industry has evolved in the last decade or so. One very important point to highlight here is that contamination is also surprisingly very, very strongly related to the supply chain itself. Having a local supply chain has multiple benefits because a lot of contaminants are actually picked up during the very act of transport alone. So when you have to transport things from across the world in ships, as someone pointed out in the morning, as Colonel Avasthi pointed out in the morning, or rather earlier, is that most of these chemicals have to be transported by sea, which means there are long contact times. And when chemicals contact any other material for a long contact time, they evolve, the contamination evolves, or new contamination forms. So localization of supply chain in that sense is a very important aspect for all semiconductor manufacturers. And then, as rightly pointed out by Mr. Singh, the environmental norms are also something that are getting more and more stringent. For example, there is a new notification or a new rule coming both in the European Union as well as in America, where there is going to be a prohibition, or there's going to be a ban on fluorinated compounds, in the sense that there's going to be a regulation, there's going to be a very strict scrutiny of any compound that contains a single fluorine bond. So those kinds of things also lead to different kinds of contamination, in the sense that you need to make newer materials bring newer challenges, so on and so forth. So one thing that comes with contamination, or two things that come with contamination, are the ability to measure. If you cannot measure, you don't know what it is. And when you don't know what it is, you cannot control it. So measurements are a very, very important part of this entire problem statement. And by measurements, I don't mean parts per million level measurements. I mean parts per trillion level measurements, consistently, reliably, day in and day out. And in things like water, people are reaching parts per quadrillion levels. So even the instruments are not available to detect that contamination. So you're literally finding one needle in a haystack. So the contamination is a problem. It's a fundamentally devastating problem, because it affects both yield as well as it affects reliability. So it's fundamentally something that is very, very important to understand. And what happens is, if you don't understand contamination, you don't know how to control it. And controlling of contamination is in itself, you may not believe it, is in itself a $2 billion industry per year, just contamination control alone. And the industry may be even bigger than that, but fundamentally it's a multi-billion-dollar industry just protecting contamination. So I'll just rest my case saying that contamination is a very important aspect. Across the 8 to 12 million metric tons of chemicals that are supplied to this industry, you need to maintain, or we need to maintain as a community, parts per trillion levels of contaminant or levels. So something to keep in mind. So the magnitude of the problem is high, but it's not intractable. It's been solved before.
Yeah, I fully agree with you, Ashutosh. I'll give just, I'll add to this. See, the processing, a little bit glimpse you have got from the morning, how complex the processing is. It is not, as he rightly pointed out, generation, manufacturing of these chemicals, or see, from the morning you are hearing the very good quality water and electricity. So generation of ultra pure water, which is needed, it is almost theoretical thing which we need in fabs. The theoretical resistivity of water is 18.2 mega ohm centimeter, 18.3. So normally all fabs have 18.2 or more. Okay, they have very, very pure water. It is not, it is just, as I said, one measure. But that water should not have oxygen, though that water should not have salts, that water should not, as he rightly pointed out earlier, there was no consideration for organic. Now total organic content has to be seen, TOC we call it. So that has to be seen. So there are almost 10 things which we measure. As he rightly pointed, measure, measure and measure. See, you have generated water and it is very costly. That generation plant, if you see, even for a small fab like which is there in Chandigarh, in the India's only fab earlier, see, it's a very small fab, but that water generation plant is almost, I'll say, about 6 to 7 times of this hall. It starts with the raw water and then it goes through many stages of purifications, and then finally that water you get after all polishing. But next part is storing, because you are storing it. So as you have seen, normally you have seen in your houses also, there is a plastic bucket. If you store the water for a few days, you will see a white layer around, okay, on the top, if you leave the water. So that is bound to be there. So rightly said, special containers. So the storage itself is very, very, I'll say, special storage arrangement, where a very glass-like finish is given to those tanks inside. And then the distribution. The next job is that water has to be taken to all equipments. And that distribution is also very critical, as has been brought out by one of the panelists, my colleague earlier, Mr. Satish, that it is very critical to take whatever purity you have generated to the equipment. Ultimately, it is the equipment where it has to perform. So it is not only, there are many parameters there. So there are almost 10 inline monitors from generation to the equipment when these things goes. So everything, like all kind of gases which you don't want, gases you want for processing, but like in water, you don't want these gases. So you are monitoring them and their purity level, like it is mentioned, and those sensors and monitors are very, very special one, because they have to monitor these purities to PPT levels. So that is very rightly said, generation and measurement till it is doing its actual work. So now I'll turn my attention to Renat. See, Renat, already there are facilities now in India. Like already one fab is being set and OSAT facilities are there. So their need is certainly now. So what steps you suggest to fulfill their requirement in short term, as well as what steps you will suggest for this ecosystem to come in India in the long term also?
Thank you for this key question. Yes, because the battle is now, and there is no choice. They need gases, they need materials, advanced materials to produce semiconductors. So I would like to articulate my explanation on three key topics. I will not repeat what was said on the quality, but the first one is really quality. How to tackle this question of the quality, the purity. Just to give you one example, when we are talking about 10 nanometers, it is 7,000 times less than the size of the human hair. And this is exactly the kind of purity, quality, impurity we are going to measure. So quality as a key component, I would suggest really to leverage on the global capabilities of industrial gas players, chemical industry, to set up and to import the knowledge, to import equipment in order to set up and learn about the quality management, the qualification, it was said just before, in terms of development of this ecosystem supporting the development of semiconductor. The second one is the supply chain. On the supply chain, the key question is the localization. When? What could be the threshold? Yes, localization for a certain number of gas and chemicals will be possible and is a must, I do agree. From some others, there is no choice. You will have to buy and you have to import those advanced materials for etching, deposition, cleaning from the worldwide ecosystem. And then you should be ready to do that. How? In my opinion, you have to facilitate really the importation to have a green corridor for this kind of gases, because today we are regulated by the peso for this kind of gas. Time to time, it's really difficult to be delivered on time, to manage a reliable supply chain. Reliability of the supply chain, sustainability of the quality are really key criteria to develop the semiconductor ecosystem. Finally, my third point will be innovation. Innovation, because this is only the beginning of the journey. Beginning of the journey for India, part of the worldwide ecosystem. And without innovation, cooperation between vendors, customers, university, PSUs, government, should allow India to grow and to develop those competencies. And innovation will be the key driver for the next wave of semiconductor in India.
Thank you, Renat. So till date we have talked about purity. So what I'll say is now that we have to deal with the highly impure things also after processing. See, till it goes to wafer, all processing is there. We feed very pure water, pure chemicals, everything. But after processing of the wafer, what comes out is a very hazardous waste. It is a very hazardous waste, and there is, as in the morning, many people have pointed out, now the people are looking at all measures for sustainability goals. So there is a lot of emphasis now on, like water also. Water, as I said, I explained you, it is very difficult to generate, and it is very costly. That generation is very costly. So a lot of emphasis is on this aspect that if we can recycle or reuse that water by doing certain management, so why not do it? And that is going to be in force in future for most of the fabs which we are seeing. But at the same time, when you see a lot of other, like they said, acids are needed for cleaning. So when everything after processing comes, it is like mix of all acids, chemicals, and that waste management itself is a job. Like somebody has pointed in the morning, there are ETPs, effluent treatment plants there, and then there is a very good system always put in fab for all the other waste collection. So with me, Mr. Sharaf is there, who is having expertise in this field. So I will request Mr. Sharaf to show some light on what are the solutions and innovations possible for waste management.
I hope I'm audible. Yeah. I hope my expertise is not only limited to waste management. There are many other areas, but
that was one of the areas I saw.
No, certainly. Yeah, I think this is, while manufacture was important, but I think these kind of issues have become very important now as to how do you not only make something, but also how do you treat the waste in an environmentally friendly manner. So I'm very happy that my 7 colleagues are here from our 3-4 companies, and all of us have different versatile expertise. One of the companies based in Baroda, Transpec, has done some wonderful work on the effluent management, especially in a very eco-friendly manner. Talking of the sewage water plants or treatment plants, generally they are very capital intensive and very lot of chemicals used and all that, but I think they have been able to find wonderful solutions which are very eco-friendly. So this is just one area. And if I may just touch on a few other related subjects, I think when we talk of the semiconductor chemicals, not only what you make, how pure you make, how you make it, how do you pack it, how do you transport it, and how do you deliver it, all this is very important. So the word ecosystem has been used since morning maybe 100 times. So I think even within the chemicals for semiconductor, the ecosystem is very important. So just to give an example, that being near to the supply, especially for gases, I think it can become very important. You might produce the best gas, but by the time you supply it over a few 100 kilometers or few 1,000 kilometers, it can get contaminated. The container itself can become a contaminant. So I think it's the whole value chain, the whole system is very important. Talking of purity, yes, high purity is important. So some of the chemicals that we have been working on for a long time, we were not only the first manufacturer of phosphoric acid way back 70 years back, we were the first to supply to Coca-Cola, who wanted food grade phosphoric acid, and we were able to remove what they did not want. Today, for semiconductors, we have been able to come out with the product which is right, and it is just on the verge of being supplied. Gases are very important. Two of the gases I will just mention that our group is working on. HBr, hydrobromic acid gas, which is going to be made so near to Dholera that it will almost like stone's throw. Phosphine is another gas. We have a lot of familiarity with that gas. So like that, our company, which is one of the oldest companies, so we have a lot of experience, a lot of pioneering efforts, and I will be happy to do. Skill development also is very extremely important. So our companies are always active in training the people, especially rural communities, even unlettered workers, how to train them into very sophisticated operations. We have always been able to do it. So we'll be happy to collaborate with the industry in ensuring that the right things are done. Even pure chemicals, while we make some pure chemicals for semiconductors, but we'll be happy to share our expertise with others who want to make pure chemicals. So looking forward to collaborative ventures. Thank you.
Thank you, Mr. Waste management, as I was saying, water, like I gave example. So the aim ultimately, like the most of the bigger fabs, the gigas, the so-called giga fabs, they are aiming for water recycling up to 70 to 80% of the input, whatever they have. Similarly, from the waste, like I said, one is water is normally, it is possible because you typically, water is used for cleaning, like in the final. So you can isolate that and you can use. But there are other solvents, so solvent waste collection is done separately. But then now the opportunities are there in that sector also. People are trying to isolate the solvents also from that waste and trying to use it for other non-critical applications. So this is waste management is very, very little understood, and there is a lot of opportunity in this field for seeing the volume of the business which is coming up in the semiconductor industry. So my...
just to add to that,
yeah.
Paucity of time? No, sorry. Okay. Due to paucity of time, I have not shared all of that.
Yeah, we can share.
Yeah, so I'll be happy to share, and as I said earlier, that we'll be happy to collaborate with anybody in that.
Sure. Thank you, sir. So my showstopper is Mr. Subir. So they are leaders actually in this industrial segment, and they have the largest cryogenic tanker fleet with them. So as we discussed, and in this panel also, in the morning also, the transportation itself is a very, very critical aspect, seeing the hazardous nature of these chemical and gases and the criticality. So I will like to ask Subir to throw some light on the gaps which you see, particularly from the transportation aspect, and what are the measures you suggest to strengthen these?
Thank you, sir. In India, the industrial landscape has been such, and particularly in our context, that we have to reimagine what we have been doing till now. Because we were in the process of, supplying to the core industries and managing their supply chain in large bulk quantities. So therefore, we have created something around 4,500 tons of liquid, which is in the merchant grade, and they are being supplied all around and hauled around. We got something in the range of about 650, tankers, which can actually haul these products across the country. And in Gujarat alone, we have got about 130, 140 tankers. So we are well equipped, but we are reimagining this because the requirements are very, very different compared to bulk supplies. So, like Mr. Singh said, that there are several areas where we can contribute, and of course we have identified gaps and some of the measures that we have to actually take to overcome them. But the quantity and the sheer magnitude of the chemicals and the industrial gases which they require, across the different stages. I have got something here. For example, we have got deposition. Fine. deposition, then lithography, and those etching, humongous. And Ashutosh was talking about, this fluorine getting banned. Now, I'm just looking at chamber cleaning. It's something where you need fluorine to a large extent. So what do you do? What are the replacements? From our experience, we see that the fab manufacturers or the OSAT guys, they are asking for helium. And then, in some places, you find there is no helium. So I asked one of them that, is it that helium is a constraint in terms of supply because of the demand-supply scenario across the globe, because of these global wars and all those kinds of things happening? They said, maybe. And we are trying to replace. Similarly, like fluorine, helium, these are some of the things which need to be replaced and rethought. But overall, if you look at the, coming back to the main question, if you look at the overall issues, that transportation, of course, the biggest problem in this environment in semicon is that you have to have the proper infrastructure. As I said, we have to reimagine. We have been doing in a hub and spoke concept, but there are specific infrastructure requirements. For example, you need to have, storage and handling facilities, which are not available. So we have to rethink, rework, and we are already ahead of the curve because we have invested in this. I can talk about my company, and similarly, the entire ecosystem has to gear up like that. And similarly, safety, regulatory, compliances. The way the safety has been done or has been imagined, normal, typical HAZOP studies that we do for putting up a large project, because I manage those large CapEx projects. They are very different compared to what the requirements are in case of your semicon and the gases that are required. Similar with the workforce, skilled or man-force, or the workforce that you need, and reskilling and reskillings are required. Because the people who have the requisite skills is the same workforce who are actually contributing into this. But as it grows, the same set of workforce with their knowledge probably will not be sufficient, so therefore reskillings are extremely, extremely important, and we need to think about them. Then there are, this is something in the forefront of technology, cutting edge, as we say. So similarly for transportation, coming to what Mr. Singh was suggesting, that how do you manage and monitor on a day-to-day basis and an hour-to-hour basis? So there are several facilities or several, things for tracking technology, for example. The supplies which you have or the storage levels, which you can actually see from a far off distance, and you can track the tankers, for example, the supply tankers. Similarly, Internet of Things, those are some of the things which can actually interface with the mobile, and you can see it yourself, and it can be done in that manner. So those are some of the things that one needs to look at, and you have to reimagine, as I said, and the ecosystem had to develop that way, because you have to think in terms of a completely different thing. I think Benoit was talking about, thickness, smaller than a hair strand. And so therefore, we can't even imagine we can't even get around, we cannot embrace this kind of concepts. So therefore, it will be, we are taking baby steps. And someone said in the morning that we have to have baby steps moving into maybe the crawl and then walking and then running, all those kinds of things. And similarly, you need to have partnership. I personally believe that there is one more important aspect that one needs to look at, is how people defined their demand. Very important. And our experience has been that the way the demand has been defined versus when the actual supplies start, they have a huge, divergence. And what happens is that you've invested in the assets or whatever you have invested in, assuming that demand is going to come through, and that is not coming through. So is there a scope for, sort of freezing the technology and suggesting that demand which have been done with proper care? Otherwise, what happens, the suppliers or the vendors or the partners, they will get completely disillusioned. If once or twice these sort of things happen, then what happens is you don't even take these things seriously, you take it on the face value. So then what happens is when the actual time comes, then you are in a tremendous stress because no one is prepared for that. So these are some of the things, other than, of course, the environmental objectivity and the environmental due diligence, which are very important because we are anyway handling all those hazardous chemicals, and therefore environment is an important element. Carbon footprint removal of that to the extent possible is very important. So these are some of the things which I would suggest, but it is work in progress. In our company, we have done a lot of work, but others would be, I'm sure, doing that work, and we need to catch up as a whole to make it successful in India as a country.
Thank you, Subir, for such a detailed your view on this. So with this, probably we'll like to wind up because we are already late. We have done our discussion in time, but because of the earlier delays. I like to conclude that as you have seen right in the morning, there are opportunities are many, be it the GDP contribution, be it the export contribution to the exports. It is right time, I think, for the established players in the country to diversify in this. But import is maybe for starting, we can have the backward integration. Right now we can have warehouses to cater to their demand, and then gradually, probably as a step, we can import the raw molecule, because Air Liquide is very much expert in the precursor molecules also. So we may import the precursor raw molecule initially and finally produce them here. That should be our goal.
I will add something, Mr. Singh. For example, you very correctly said, we used to import nitrous oxide. Nitrous oxide is something which is used in medical space, as you know, with child bath and all. Nitrous oxide is something which is required here as well. So we used to import the specialty variety of nitrous oxide. But now we have put up a plant in Manali, in south. So just, echoing what you said just now, and that is what we are doing. But I think Ashutosh made it very clear that if it comes all the way from a distance of, thousands of kilometers, then there, of course, there would be contamination, there will be all those things. Shelf life, all those things have to be taken into consideration.
Yeah, yes,
so warehousing is important, processing of chemicals there will be important before it actually reaches the consumption point. That, according to me, is
I
important.
think very well said. So with this, we conclude our session. Thank you very much. Thank you for listening patiently.
Thank you very much, sir, for moderating the session well, and also thank you, panelists, for doing the job very precisely. I would request Dr. Narottam Sahu to kindly present the mementos to our panelists and then to the moderator, sir. And ladies and gentlemen, we request you to kindly be over here by 3:10 so that we can timely start the event. Ma'am will have to give an hour because it takes a while for them to go have their lunch and come back. And but we are happy to say that we are first than the seminar hall number 2. So please enjoy the lunch and come back timely because we have 2 important sessions over here. And anyone who gets the bag of Ms. Gurpreet, kindly hand it over here at the sound team. Thank you so much. The 3 esteemed speakers of the morning, you'll have to join them for the group photograph. So if you can do it, all 3 of you. Colonel, sir. Yeah, all 3 of you, and together the panelist and the moderator, sir. Thank you.
Hello, mic testing, 1, 2, 3, hello, okay.
Yes, sir.